In the index number chapter, we have learned how to calculate Fisher index number. This method is called ideal index number test because Fisher's method satisfies the time reversal test and factor reversal test. So, the theory of the Fisher ideal index number we have discussed in our last video. In today's video, we will having two questions related to the Fisher ideal index number. Both two questions are very important as far as the examination is concerned. I have seen so many times these questions are repeating in the examinations. So first question I have written on the blackboard. The base year is 2020. On the behalf of the base year, we are to calculate the Fisher ideal index number for the current year, that is 2024. The price of the base year is given for commodity A, B and C. There are three commodity. These are A, B, C. The price of the A in 2020 is 4 rupees. The price of B is 3 rupees and price of C is 2 rupees. The quantity purchased by a person, that is A is 50, B is 10 and C is 5. In current year, the price of the A item is increased from 4 rupees to 10 rupees. Price of the B item increased to 3 rupees to 8 rupees and price of the C item is increased to 2 rupees, 4 rupees. The quantity, due to the increase in the price, he is purchasing less quantity. Firstly, he was purchasing 50, now he is having 40. B commodity, firstly he was purchasing 10, now he is purchasing only 8, and the C commodity also he is decreasing the quantity. So we are to calculate the Fisher ideal index number. So the very first for we will calculate P0 Q0, then P1 Q0, then P0 Q1 and last P1 Q1. So the very first we will calculate the P0 Q0. So P0 and Q0, 4 multiplied by 50, that is 200. 3 multiplied by 10, that is 30. And 2 multiplied by 5, that is 10. So this will be 240. That is sigma P0 Q0. P1 Q0. So first one is 50 multiplied by 10, that is 500. Second one, 10 multiplied by 8 is 80. Third one is 5 multiplied by 4, that is 20. So the addition of this will be 600. Third one, P0 and Q1, 4 multiplied 40, that is 160. 3 multiply 8, that is 24. 2 multiply 4, that is 8. So the addition of this, that 160 plus 24 plus 8, that is 160 plus 24 plus 8, that is 192. Next one, 10 multiply 40, that is 400. 8 multiply 8, that is 64. And 4 multiply 4, that is 16. So this is 400 plus 64 plus 16. So that is 480. 480, 192, 600 and 240. Okay. So that is 480. That is sigma P1 Q1. This is sigma P0 Q1. This is P1 Q0 sigma. For Fisher ideal index number, P01, 10 multiply 11, 00 multiply 01. So P01, that is sigma P1 Q0 divided by sigma P0 Q0 multiply by sigma P1 Q1 multiply by P0 Q1 multiply by 100. So Fisher ideal index number, we have to put the value of this. First one, P1 Q0. P1 Q0 is 600. Divided by P0 Q0, that is 240. Multiply by P1 Q1, that is 480. Divided by P0 Q1, that is 192. Multiply by 100. So getting the calculation of this, 600 divided by 240, 2.5. 480 divided by 192, that is also 2.5. Multiply by 100. So P01, this is 2.5 multiplied by 100. So P01 value is 250. So the Fisher ideal index number value is 250. So the index number value is 250. The very first we have to do this. So the very first we have to calculate the value of Fisher ideal index number, that is 250. Now we will having why this is called ideal index number. So the very first we will satisfy the time reversal test. Later we will discuss for the factor reversal test. So the very first we have done this, no problem at all. Now we can move with this. Sigma P0 Q0 is 240. Okay. Sigma P1 Q0, that is 600. Sigma P1 Q1, that is 480. Sigma P0 Q1, that is 192. So first we have right here. Now come to the point. First one we discuss the time reversal test. First one test is time reversal test. Time reversal test. Time reversal test. Index number of current year on the basis of base year and index number of the base year on the basis of current year. The multiplication should be 1. So P01. P01 already we have written, that is sigma P1 Q0 divided by sigma P0 Q0 multiplied by sigma P1 Q1 divided by sigma P0 Q1. Now change 1 to 0, 0 to 1. P1 0, P1 P0, Q0 Q1 divided by P0 0 to 1, and 0 to 1, 1 to 0, 1 to 0 divided by 0 to 1 change or 1 to 0. What we are to do? We have to change. What we want to change? We will do 1 to 0, 0 to 1. This change we have done. So P01. What we have done? This is 1, so this is 0. This is 0, so 1. 1 1 0 0 0 0 1 1 0 1 1 0. Now this value is P1 Q0. P1 Q0, that is 600 divided by P0 Q0 240. Multiply by both. P0 we are having P01 guna P10. So 600 divided by 240 multiply by 480 divided by 192 multiply P0 Q1 that is 192. P1 Q1 480 multiply P0 Q0 240 divided by 600. So 600 up and down, 480 192 240. So P01 guna P10 under root 1, that is P01 guna P10, that is 1. So it proves that this question satisfies the time reversal test, because the multiplication of P01 into P10 is equal to 1. Next, for the factor reversal test. Factor reversal test, price index multiplied by the quantity index should be equal to P1 Q1 divided by sigma P0 Q0. Okay, so P01, that is sigma P1 Q0, this is 10, divided by sigma P0 Q0 multiply sigma P1 Q1 divided by sigma P0 Q1. Now quantity index. In quantity index we will write P1 to Q1, P to Q, Q to P. So sigma P1 that is Q1, Q0 that is P0 divided by P0 change to Q0, Q0 change to P0, multiply P1 change to Q1, Q1 change to P1, P0 change to Q0, Q1 change to P1. So P01 that is 600 divided 240 multiply 480 divided 192. Q01 that is 192 divided by P240 480 divided by 60. So multiply with the both P01 guna Q01 that is 600 divided by 240 multiply by 480 192 multiply 192 upon 240 multiply 480 upon 600. So 240 600 up 600 down 192 plus 192 down. So P01 guna Q01 is having 480 raised to power 2 divided by 240 raised to power 2. So P01 guna Q01 that is sigma 480 divided 240. So sigma P1 Q1 but the sigma P0 Q0. So it's proved that this question satisfy the factor reversal test also. So with the help of the factor reversal test also this question is satisfied. So we will say if question from the Fisher ideal index number is over there, so the very first you have to solve the question. How to solve the question, that is okay. Then you have to discuss if they ask that calculate the Fisher ideal index number, then you have to show these two tests. If they in question only the written that calculate Fisher index number, then you do not want to write these tests. One more question for the practice we will doing. So it will make you the perfection in Fisher's ideal index number. Any type of the question is over there, then you may be able to solve this. So I am having one more question for the Fisher ideal index number. Base year price base year 2021 is given as a base year. The price of A, B, C, D, E product, the price is given, that is called P0 62410 62410 and quantity purchase on the base year is 50 100 60 30 40 50 100 60 30 and 40. Current year 2025 is current year. 24 I should write, otherwise you will be confused. 20 current year price is P1, that is 10 to 6 12 12 10 to 6 12 12. Current year quantity the 50 to 56 120 60 24 36. This question is given on the behalf of the base year. Calculate the Fisher's ideal index number for the 2024. The price of the base year is given, that is 6 rupees, 2 rupees, 4 rupees, 10 rupees, 8 rupees. The quantity purchased in base year is 50, 100, 60, 30, 40. The price increases to 6 to 10, 2 to 2, 4 to 6, 10 to 12, 8 to 12. And the quantity also increasing 50 to 56, 100 to 120, 60 is equal, 30 to decrease 24, 40 to decrease 36. So for first we will calculate P0 Q0, then P1 Q0, P1 and Q0, then P0 and Q1, and last one P1 Q1. Firstly we got the multiplication of this. So first one is 6 multiplied by 50, that is 300. Now 2 multiplied by 100, that is 200. 4 multiplied by 60, that is 240. 10 multiply this, that is 300. And last 8 multiplied by 40, that is 320. So the addition of this is 1360, that is sigma P0 Q0. Next P1 Q0, 50 multiplied by 10, first one is 500. 10 multiplied by 200. 6 multiplied by 36, 360. Then 360. 480. So 1900. That is sigma P1 Q0. P0 Q1, 6 multiplied by 56. That is 336. 2 multiply 120. That is 240. 4 multiply 60. That is also 240. 10 multiply 24. That is also 240. 8 multiply 36. That is 288. So the addition of this is 1344. That is sigma P0 Q1. Last one P1 Q1. First one is 560. 12 2 guna 120. That is 240. 6 guna 36 is 360. 6 guna 60. 12 guna 24. That is 288. And last one 12 multiplied by 36, that is 432. So the addition of this is 1880, that is sigma P1 Q1. Now for Fisher ideal index number, 10 multiply 11, 00 multiply 01. So P01, that is sigma P1 Q0 divided by sigma P0 Q0 multiplied by sigma P1 Q1 divided by sigma P0 Q1 multiplied by 100. For getting P01 value, we are having first one P1 Q0, that is 1900 divided by 1360 multiply 1880 divided by 1344 multiply by 100. So we will calculate this. That is 1900 multiplied by 1880 divide by 1360 againly divide by 1344, that is under root P01, that is under root 1.9542 multiplied by 100. So getting the under root of this multiply by 100, we are having 139.79. So answer is 139.79. Or we can write 139.8. So this is Fisher ideal index number for this. Now it is called ideal index number. So just for that, we are having just 2 or 5 minutes. First one is time reversal test. Time reversal test is index number of current year on the basis of base year and index number of the base year on the basis of current year. The multiplication should be 1. So P01 value is already we have sigma P1 Q0 divided by sigma P0 Q0 multiplied by sigma P1 Q1 divided by sigma P0 Q1 and P10, that is sigma P0 Q1 divided by sigma P1 Q1 sigma P0 Q0 divided by sigma P1 Q0. What we have done? 1 to 0, 0 to 1, 1 1 0 0, 0 0 1 1, 0 1 1 0. So having P01 guna P10 multiply in both, that will be, first one is 1900 divided by 1360 multiply 80 divided by 1344 multiply P0Q1 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 1344 P1Q1 1880 P0Q0 that is 1360 divided by 1900. So 1900 this to this cross 1630 1360 1880 1880 1344 1344. So under root 1 that is 1. So P01 guna P10 is equal to 1. First is satisfied. Now second test. This test is satisfied. It's very easy. The second test is called, what we have to do? Just we have to put the value of this. Firstly put the value and 1 to 0, 0 to 1 change, because here 0, here 1, 1 to 0, 0 1. That will be okay here. Okay. Now the quantity reversal test, that is called factor reversal test. Factor reversal test is P01 guna Q01 is sigma P1 Q1 divided by sigma P0 Q0. So just we have to put the value P01, that is sigma P1 Q0 divided by sigma P0 Q0 multiply by sigma P1 Q1 sigma P0 Q1. Quantity index, that is sigma P0 Q1 divided by sigma P0 Q0 sigma P1 Q1 divided by sigma P1 Q0. So putting the value P01 guna Q01, that is 1900 divided 1360 multiply 1880 1344 multiply 1344 upon 1360 multiply 1880 divided 1900. So 1900 to cancel, 1344 to cancel. So P01 guna Q01, that is 1880 square divided 1360 square. So equal to P01 guna Q01, that is sigma P1 Q1. It's proved. So with the help of this you can having. So I think this video will be helpful for you to know how to solve Fisher's ideal index number problem is over there. If any type of the question is over there, by step we will go, you can certainly do this question. So thank you.